Okay, we want to try to put polynomial graphs in a little bit of perspective, understanding what we do about power functions, and also about the fact, as we've seen previously, that when you expand a polynomial, if x has a large positive or large negative value, the higher power terms, the highest power term in that polynomial eventually completely overpowers any lower power term. Okay, it's kind of why we call it power. So x cubed has much more power than x squared. And you can check it out. Okay, matter of fact, we're going to do that. Okay, you can also check out that if you expand this, these are the first two terms, and there's an x term and a constant term, and they don't amount to a hill of beans when x gets large compared to x cubed. Okay, and we've discussed this. So we're going to assume we understand it. Again, you can check, you can do the expansion yourself and see that these are the first two terms. If I try to draw this graph on a scale that goes from x equals -20 to +20, x cubed is going to take values that go down to -8,000 and up to 8,000. 7x squared is going to take values of 2,800. Okay, and 2,800 is significant compared to 8,000. Okay, there's 8,000, 2,800 is about this much. But it's not a huge part. The 8,000 beats the 2,800, at least fairly convincingly. Okay, so what I want to do is I want to draw the graph of x cubed. Just x cubed, okay? And I'll have the point -20, -8,000, and 28,000. Another property of the cubing graph is if x becomes half as great, well, the cube of a half is 1/8. And you can think about it a little bit and see that anytime x gets half as big, the cube is going to become 1/8 as big. So here's my value of x when x is -20. If I want the value when x is -10, it's going to be 1/8 of this. Well, that's convenient because I can subdivide this. There's half of the -8,000, should be a little lower than that. And half of that, that's a fourth of this, and half of that is 1/8. Okay, so that at -10, the value is going to be like right about here. Of course, right in the middle of my number, -10, which we can't really see anymore, but we know it's there. Okay, and of course, when x is 10, we can subdivide this and subdivide it and subdivide it again, and we see we're going to have a value about here. And we could do a value for -5, be 8 times closer to the x-axis than this one, which is going to put it almost right on the x-axis. And of course, we go through 0, so here is a reasonable graph of y equals x cubed. Now we know from what we know quite well now, I think, that the graph of this function is going to have to go through 0 when x is -5, and again when x is -3, and again when x equals 1. So we've got these 3 points where the graph has to go through 0. Now we really can't see that here because the line I made with this chalk is way too thick. But we can still try to draw it. If you take account of the fact that 7x squared is 2,800, when x is -20 or 20, come up from this point that far, come up from this point that far, and we have a couple of points that are going to lie on this graph, or at least something close to this. So now we're going to have to come up here. We're going to go through 0 here, and then we're going to come down here, and then we're going to come up here, and then we're going to go on up. I didn't draw that very well. I've exaggerated how high these humps are on this scale. But the graph of the function looks something like that. Now let's take a little better look at it, and let's look at it on this scale. Okay, so from negative 10 to 10, when x is negative 10, x cubed is negative 1,000. When x is 10, x cubed is 1,000. We get twice as close. We're going to be 8 times as close. So I'm just going to kind of fudge where these points are. Okay. And here's going to be my graph of x cubed. Now, when x is negative 10, 7x squared is actually fairly big compared to x cubed, a lot bigger than the comparison. Well, it's going to be like 700. Okay, this is only 1,000 here. If I add 700 to this, well, if this distance is 1,000, this distance is 700, it's going to give us a point about here. Okay, now I could add 700 to this point, that's just going to raise it up a little higher than we go. It's going to raise it up to, well, it's going to be way up there. Okay, so I have a point here on the graph. There's going to be a point out here. It's going to be a lot higher. At negative 5, got to go through 0. Negative 3 has got to go through the x-axis. And at 1, it's got to go through the x-axis. I've got to have a point here, and a point here. Well, knowing that I've got to come from here, go up here, down through here, back up through here, then go up high, I can draw a reasonable facsimile of the graph. Okay, now from this graph, it's not totally clear that the graph is going to closely approach the green graph. Our x scale hasn't gone far enough to show that. So we want to see how the behavior at the zeros is embedded in the behavior of the x cubed function. And the exercise you're going to have ask you to take a little closer look at that. After you do the exercise, you might want to come back and look at what I've told you here.